All right, guys, we're going to look at number 9 and number 10 and get it out the way. Now, it says here, according to recent research, the mean height for women in the United States is 63.7 inches, and the standard deviation is 2.7 inches. The normal graph below is marked with the mean and heights that are 1 and 2 standard deviations above and below the mean. There is our standard normal distribution curve. And it says here, make an educated guess on the percentage of the total shaded area between 58.3 inches and 69.1 inches. Okay. Now, I'm going to state the empirical rule for normal distribution. Let me use some brighter colors in this case. Do orange. Now, right here, the middle value is the mean. We can call it mu, which is population mean, or X bar, which is sample mean. But in this case, it says United States. So we're going to keep it as the population mean, which is mu. Now, it states using the empirical rule that, matter of fact, let me do it like this. About 68% of your data is one standard deviation from the mean in both directions. About 68%. When it comes to 2 standard deviations, about 95% of your data will lie within 2 standard deviations of your mean. And last but not least, about 99.7% of your data, of your normally distributed data, lies within 3 standard deviations in both directions from the mean. Therefore, if it's asking us to make an educated guess on the percentage of total area that is between 58.3 inches and 69.1 inches, 58.3, 69.1, that is about 95%. And that is the answer to question number 9. Rather, let's say about 95%. Because this is not a perfect 95%, as you will learn about in statistics. Now, number 10. It says the annual precipitation for one city is normally distributed with a mean of 27.5 inches and a standard deviation of 3.2 inches. You want to fill in the blank. In 99.7% of the years, the precipitation in the city is between what 2 inches? Okay. It says it is normally distributed. So I'm going to draw my bell-shaped curve, which I'm not too good at drawing, but this looks pretty good. And remember, the mean goes in the middle. The mean value in this case is going to be 27.5 inches. Now, I'm going to put 3 units, 3 tacks on the right side. 1, 2, 3. That are supposed to be evenly spaced apart. And 3 on the left side. 1, 2, 3. And to find these values to the right and to the left, we're going to apply the standard deviation. Remember, the standard deviation is an approximate average between the data value and the mean of the data set. I'm going to put mu in the middle. So I'm going to work my standard deviation. As I move to the right, I'm going to be adding 3.2 to 27.5. And I'm going to add 3.2 every time. So 27.5 plus 3.2. That is going to be 30.8. Add another 3.2. That is 34. And then 37.2. Matter of fact, not even. I have to work on my math. I should be using a calculator. That's going to be 30.7, 33.9, and then we're going to have 37.1. So I apologize for adding it incorrectly. On this end, we're going to subtract 3.2 starting from 27.5. So that's going to be 24.3, 21.1, and then we're going to have 17.9. Going back to the last question, remember, 99.7% represents 3 standard deviations from the mean in both directions. Therefore, if I'm looking at 3 standard deviations from the mean in both directions, that is going to be 17.9 and 37.1 inches. So to fill in the blank, that is going to be 17.9 and 37.1. That is the answer to number 10. All right, guys. Hope you enjoyed the video. Hope you understand how to find, your standard deviations and your percentage using the empirical rule. Make sure that you have this down, this rule right here. Matter of fact, I want you guys to take these notes right here for number 8, just to make sure that you remember that. All right, guys. I'll see you soon. Take care.